So we use a distributive property to simplify expressions. So this is sort of the example with variables, but this works with numbers as well. And so what we're going to do a lot today is doing the distributive property with numbers. But it shows it here with variables just because it can work with any set of numbers and or variables. So what the distributive property does is it is multiplying the number that's outside of the parentheses to each number inside of the parentheses. So what this becomes is A times B. Do you see that? Plus A times C. So we multiply in that coefficient to each term. Okay? Kellen.
What if there were two numbers, if you put them right next to each other, it wouldn't be times, like, it would just be one different number?
This would be times right here. But you're right, if it was two numbers, we'd just do the multiplication and put that number there. I'll show you. I'm going to show you with numbers. Don't worry. We don't have to be abstract the whole time. So I'm going to show you with numbers. For example, with numbers and variables, because we'll see this a lot now that we're sort of moving into more pre-algebra. If we have an example like this, 4, and we say this 4 times the quantity. So when you see parentheses, you say that 4 times the quantity, 2x plus 1. In order to simplify this, we are going to multiply this 4 into both terms inside the parentheses. Now, think about order of operations. Usually our first step is to simplify inside the parentheses. But we need the distributive property now because can we simplify inside those parentheses? No, because why, Finn?
We don't know x.
We don't know x, but more specifically, they're not like terms.
Oh, yeah.
They're not like terms.
Also, have we learned about this at the beginning of the year?
So what we're going to do is multiply the 4 into both of the terms. So what is 4 times 2x? We work with the coefficient. So we do 4 times 2 and put the x on the end. Lily? 8x. 4 times 2 is 8. And the x just stays there. So we're doing 2x 4 times. 2x, 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 2x. That's 8x. Okay? And then we're going to multiply the 4 by the second term. 4 times 1 is 4. Okay, and this was a positive 4 we are adding. So the simplified distributed expression is 8x plus 4. Let's do another one. Okay, negatives. When we have negative signs, you cannot forget about the negative signs. Those always matter. So make sure you use those in your distribution. This is a negative 2 times the quantity, y plus 7. So we need to multiply each term by negative 2. Negative 2 times y is going to give me what? Kellen? Negative 2y. And then we're going to multiply negative 2 times 7. Negative 2 times 7 is what? John?
Would you still times it?
Yep.
Negative 14.
Negative 14. So all I need to do is write minus 14. So we don't need to be differentiating anymore between subtraction and negatives. They're the same thing. So this is negative 2y minus 14.
And so you don't have to put the plus when it's
No. Now what you're asking is, could we say this? Negative 2y plus negative 14.
Yeah.
Yeah, that is right. But can we get into the habit of starting to eliminate saying plus a minus and knowing that that's actually a negative or a minus? Let's work on that, okay? All right. Can you do this one on your own? 3 times the quantity, 6x plus 4. 3 times the quantity, 6x plus 4. Distribute this 3 to both terms in the parentheses. Oliver.
So will it be incorrect if you still say plus a negative number?
Pretty soon it's going to be incorrect if you say this. I need you to give me simplest form. Okay? So pretty soon it's going to be incorrect. Let's start getting into the habit of putting it in simplest form. Plus a minus is just a minus. All right, what did we get for 3 times the quantity 6x plus 4? Bridget.
18x plus 12.
Good. 18x plus 12. That is correct. Is when we have, so in the examples we did before, we had a plus sign in between our terms in the parentheses. We can also have a minus sign. Okay, so we can have something on the outside, and then our term or our expression inside the parentheses might be separated by a negative sign. The negative sign always goes with the second term. So we treat that as a negative number and multiply. For example,
Also, it's a number.
let's look at what this looks like in actual work, not just a bunch of letters. 2 times the quantity x minus 3.
Should we do that?
So the first step, we're going to use the distributive property. We're going to multiply the 2 to both terms inside the parentheses. So our first term would be 2 times x, which is 2x. And our second term is 2 times negative 3, which is what? John?
-6.
Negative 6.
That's
And that's it. That's it. That is it.
not bad.
Okay? So you just have to keep the signs with the number and make sure you use the sign when you're doing your multiplication. Nicholas.
Can there, like, in the parentheses, can there be like a plus and then like a negative third side?
Probably not. They won't. His question was, will there be like a plus, a minus? Probably not, because that's not simplest form. They're not going to give you that anymore. It'll just be a minus. Let's do another one. Bless you. All right, can you do this one? Can you do this one? We're going to use the distributive property to multiply 3 times the quantity -4 minus 2y. Our first step is to do 3 times -4. Natalie, what'd you get?
I got -12, -6y.
Good. So we did 3 times -4 is -12. And then we do 3 times -2y, which is -6y. So the way that we would say this expression is -12 minus 6y. Okay? All right. Let's do another one. Okay, watch what happens here. -2 times the quantity 2x minus 1. We'll start by multiplying in, distributing in that -2 times -2 times positive 2x, which gives us what? What's our first term? What is it? -4x. Good. -4x. And then we will multiply -2 times -1, which gives us what, Dane? What kind of 2? Positive 2, because it's a -2 times a -1. A negative times a negative will be a positive number. So this becomes plus
And then that's
2. Okay? Do you all see how that happened?
yeah.
Okay. Good? All right, let's do a couple examples. Now, these should be easy because we actually already did a bunch of examples. Yeah. Yep. Okay, now, good old fractions, they're not gone. So you need to remember your rules for multiplying fractions. Feel free to take the fraction part aside and do your multiplication in order to do this correctly. Distribute in the -1/3. So we're going to multiply. This is really -1/3 times what? 3 over 1 n, right? Big number 3 is really 3 over 1. Addison.
Can there be a fraction inside the parentheses?
Yes, there can be a fraction inside the parentheses. You just deal with it the same way you multiply. Okay, so multiplying fractions. So when we do this, -3 times 3 over 1, we can cross simplify. So then we just get what? Negative n, -1n, or -n, right?
It's always times.
Always times. Then we do -1/3 times what?
6 over 1.
What kind of?
-6.
Yes, don't forget it's a -6. -1/3 times negative 6 over 1. Cross simplify. And we get 2. Is it going to be positive 2 or negative 2? Positive 2. Because it was a negative times a negative. So that's kind of nice. When we multiplied in the fraction, it ended up getting rid of the fractions. Aiden.
Is it incorrect if you put negative 1 in?
No, it is not incorrect if you put negative 1 in. So he's asking if you put this. That's fine. That's fine. But it's imaginary, like it's like an imaginary 1. Just like if we say n, that really means 1n. It's the same thing if we say negative n. So it's not wrong. No. It's implied, exactly. Okay, let's do another one. 5 times negative x plus 3y. You should all be able to do this in your notes. You should all be able to do this by now. We've done a lot of practice. Can you distribute 5 into that quantity? Caroline, what'd you get?
Negative 5x plus 15y.
Very good. Negative 5x plus 15y. And we can't simplify further because why?
They're different variables.
They're not like terms. Very good. They're different variables. They're not like terms. So this is our final answer. Simplest form. Okay, a couple to try on your own. Number one, try this on your own. Multiply in that negative 1 to both terms, remembering your negative sign. Okay, John, tell me what you got.
Negative 1x plus 9.
Negative 1x, that is correct. What's the second part? What should your second term be?
Negative 9.
Yes, minus 9. Okay, you could also say this, negative x minus 9. That is also correct. So either one is the correct answer. Okay, last one. One with the fraction. Let's try this in our notes. 2/3 times the quantity negative 3z minus 6. Vika, work it for me. What'd you get?
Negative 2z minus 4.
Good. Negative 2z minus 4. That is correct. How did we do? There are two methods for doing a problem like this where you have 3 terms in the parentheses. You can use either. I'm going to show you both, and then you can decide which one you like. Method 1 is to distribute the negative 3 to each term. So negative 3 times the quantity negative 1 plus 2x plus 7. So distribute the negative 3 and then combine like terms. So we're going to distribute it to each term. Negative 3 times negative 1 is what? Nicholas, positive 3. Negative 3 times 2x is what?
Negative 6.
Negative 6x. And negative 3 times 7, negative 21. So you can do it this way, distribute to every term, and then you must combine like terms at the end. Do you see our like terms here? 3 and negative 21. We have to combine those to be totally done and in simplest form. When we do that, we end up with negative 6x, and negative 21 minus 3 is negative 18.
Oh, so if we did that because 3 and 21 both don't have.
They're constants, and we can come. They're like terms, exactly. All right, method 2 is to first combine the like terms in the parentheses and then distribute. Combine the like terms in the parentheses and then distribute. So this is just a different way to do it. You will get the same answer both ways.
It's just like opposites.
Yeah, it's just 2 different ways to do it, depending on which step you want to do first. What are the like terms inside the parentheses that we can combine? Hazen?
Negative 1 plus 7.
Very good. So if we combine those, we get negative 3 times, what's negative 1 plus 7? Finn?
Negative 6.
Positive 6, good. Plus 2x, and then distribute. So then we just go back to our old distribution. Negative 3 times 6 is negative 18. And then negative 3 times 2x is negative 6x. Now, these are in a different order. Is that okay?
Yeah.
Is that the same answer? Yes. What property says we can put those in any order? Hazen. Commutative property. We can put those in any order as long as the sign is correct in front of the term. Okay? So either way is correct. Choose the one that makes the most sense to you. All right. I'm not going to do a try it because we've done enough try it's. Let's do one like this. All right. We've got a few different terms here. The first thing we need to do, bless you. Notice this little guy outside of the parentheses. Okay? That is not something that we would distribute to because it's not in the parentheses. It's a term that's going to end up getting combined later. Okay? Our first step is to do what? Distribute. Our first step is to distribute the negative 1/2 into both of those terms. And then we'll just bring down that plus 2n in order to combine like terms. So let's start by distributing negative 1/2 times 6 over 1n. We get 1, 3. So what is our first term here going to be? Negative 3n. And then when we multiply negative 1/2 times 4 over 1, we get negative 2. And then we bring down plus 2n. Okay? And then we need to finish up because we need to combine like terms in order to get this into simplest form. What are my like terms here? Kellen?
2n and 3 and negative 3.
Good. 2n and negative 3n. So we need to combine those. What do we get? Negative 3n plus 2n is what, Finn?
Just negative n or negative 1.
Very good. Negative n or negative 1n minus 2. Bridget.
Can there be, so like if you didn't, and you didn't get 1 at the bottom, like when you're multiplying, distributing, could you put that fraction still in there?
Yes. Yep. Yeah, so her question is if you don't end up with a whole number when you distribute and you end up still with a fraction, you can leave a fraction as your coefficient. Yes.
Will big ideas take will big ideas take like negative 1n?
I'm not sure. I'm not sure if it'll take it or not. As you get farther along, it won't, but it's been pretty lenient. Like it took plus or minus, right? So like it might be because it knows that you're learning. Let's do one more. Okay, now we've got two expressions. Let's look at how we need to do this. Now we talked in our last lesson, the second lesson in the chapter, about distributing or about subtracting expressions. But here's what I want to do. We're going to take this as a negative 8 and distribute it in to both of these terms. Okay? The first expression is going to stay exactly the same, 6d minus 5. We'll take it out of its parentheses. And then we need to distribute in the negative 8 in order to figure out how to combine these like terms, because we can't combine them until we distribute. So let's do negative 8 over 1 times 3 over 4d. Cross simplify. So what do we get? Hazen, do you have a question? Yes.
Why are the numbers, why are they never uppercase?
That's a good question. I'm not sure. They always use lowercase variables. I don't know why particularly.
Negative 6.
Thank you. Okay, what is it, John?
Negative 60.
Negative 6d. Okay, so then we get minus 6d. And then we do negative 8 times negative 1, which gives us what? Ben? plus 8. Are you guys with me? How we did that? Okay, now we need to combine like terms because we can't leave it like this. It's not simplest form. Give me one set of like terms. Alexis.
60 and negative 6.
Good. 6D and negative 6D. When we combine those, what do we get?
0.
0. 6D minus 6D is 0. You have nothing left. You have nothing left. So we don't even need to write that. We don't need to write that because if we put a 0 here, let's just do it just to see what ends up happening. And then our other two like terms are negative 5 and 8.
Yeah.
And what does that equal?
Positive 3.
Positive 3. So let's simplify. What is 0 plus 3? 3. So you don't even need to put that 0 if you simplify and end up with a 0. So the answer here is just 3. Okay? How did I get 3?